Hi guys, welcome you all to my channel Explore Edu to Teach.
So in the last class we learned about the introduction to electronics devices and circuit, wherein we learned certain basic terminologies. If you haven't watched the video, please go and watch it out. It is there in my electronic device and circuit playlist. Also you'll be finding it in the I button over here. Please go and watch it out. That is the most basic video for this subject. There are different terminologies explained in that particular video. If you see regarding what is atomic number, atomic mass number, what are energy bands, what are the type and the components in the energy bands, what do you mean by different type of materials, so on and so forth. So that is a very important video. Please go and watch it out. That will help you in all the future concepts that we are going to learn in this particular subject. Today we'll be talking about semiconductors, the different type of semiconductors, the equations related to them, and the energy band diagram for the same. How does doping in a particular semiconductor makes changes in the energy band diagram? So let's begin. So semiconductors can be basically divided into two types. One is the intrinsic semiconductor, other one is the extrinsic semiconductor. As you can see over here, the intrinsic semiconductor is a pure semiconductor, whereas a extrinsic semiconductor is an impure semiconductor. When I say impure, that means there is certain additional doping which is done, which makes the intrinsic or the pure semiconductor a extrinsic semiconductor. The extrinsic semiconductor can be divided into N-type as well as P-type. So I hope I am very clear. The semiconductors can be divided into two types. One is the intrinsic or pure semiconductor. The other one is the extrinsic or impure semiconductor. The extrinsic semiconductor can be divided into two types, that is the N-type and the P-type of semiconductors. Now the intrinsic semiconductors is basically a very pure form of semiconductor. Fine. An intrinsic semiconductor is a very pure form of semiconductor. There is no doping done in such kind of semiconductor. Whereas if I talk about extrinsic semiconductors, there is certain amount of doping which is done. Let us try to find out the conductivity equation. This sigma stands for conductivity. Conductivity equation for a intrinsic kind of semiconductor. And what do you mean by intrinsic semiconductor? It means that the number of electrons and protons are equal, or you can say mainly there is no doping. It is very pure. So the sigma I or the intrinsic semiconductor is equal to mu n into Ni plus mu p into Ni the whole into Q. Now if you see, the Ni can be taken as common. Hence you have mu n plus mu p into Ni into Q. Now this equation is the conductivity of an intrinsic semiconductor. The mu n and the mu p is the mobility of electrons and hole respectively. Ni is the intrinsic concentration and Q is the charge of an electron, which I have taught you in the last class, which is equal to 1.6 into 10 raised to minus 19 coulomb. Similarly, you have the N-type of semiconductor. The N-type or the extrinsic semiconductor is basically a type of semiconductor which is basically doped with pentavalent atoms. I hope I am very clear. A N-type of semiconductor is a kind of semiconductor in which the doping happens. Okay, if you see in an intrinsic semiconductor, there is no doping. But when you talk about an extrinsic semiconductor, there will be a doping. And the N-type of semiconductor is doped with pentavalent atoms. I hope I am very clear with this. A N-type of semiconductor is doped with pentavalent atoms. I hope I am very clear. The pentavalent atoms stand for phosphorus, arsenic, antimony and bismuth. So basically a N-type of semiconductor has holes as majority charge carriers, electrons as majority charge carriers, and holes as minority charge carriers, and these pentavalent atoms are donor atoms. So I want to make things very clear. A extrinsic semiconductor will never be pure, it will have certain doping, and what makes a N type of semiconductor? A N type of semiconductor is basically talked about the doping with a pentavalent atoms. I hope I am very clear with this. Now pentavalent atoms stand for phosphorus, arsenic, antimony, bismuth. Okay, so in this kind of semiconductor, electrons are majority charge carriers and holes are minority charge carriers. These pentavalent atoms are called as donor atoms. Now if you talk about the energy diagram, you have a conduction band, you have a valence band. The lowest energy of conduction band is EC. The highest energy of valence band is EV. And now what is the addition is, because of this pentavalent doping which I am talking about, pentavalent atom doping, there is an extra energy level which gets created, which is called as ED. Okay, and ED is because of the donor impurities. I hope I am very clear. The ED energy level is because of the donor impurity. You always had EC, you always had EV, but because of the doping that happens, because of the impurity, we have something called as ED. Now the sigma n is equal to, that is the conductivity of a n type semiconductor, is equal to mu n into n plus mu p into p, the whole into q. Okay, wherein sigma n stands for the conductivity of a n type semiconductor. The n is the electron concentration, the p is the hole concentration. We have a standard equation. This is a very important equation. You should remember this. The Ni square is equal to Np. It's a very standard equation. You should remember this. Ni square is equal to Np. Since we are talking about a extrinsic N type of semiconductor, we have P which can be given as Ni square by N, because we have to write terms in terms of N, right? It's an N type of semiconductor. Hence we have sigma n is equal to mu n into n plus mu p. The p is given as Ni square by N into the whole q. This is the conductivity equation of N type of semiconductor. Now we are talking about a P type semiconductor. So a P type extrinsic semiconductor, obviously the word extrinsic means there is a doping, and the doping is of trivalent atoms. Hence it is called a P type semiconductor. Now what are the example of trivalent atoms? We have boron, aluminium, gallium, indium. So in this I can say the electrons, if you remember, in case of N type of semiconductor, you can always do a comparative study to remember the concepts easily. In N type semiconductor, electrons are majority and holes are minority. Whereas in P type semiconductor, the electrons are minority and holes are majority. So the energy band diagram again gets modified. We have EC, we have EV, and this time we don't have ED. We have EA, where EA stands for the energy level because of the acceptor kind of doping. Fine. So we have this equation, sigma p is equal to mu n into n plus mu p into p, the whole q, and sigma p stands for the conductivity of P type of semiconductor. I hope I am very clear. Now, so this is the then what you can do is that again use this equation, Ni square is equal to Np, which is given over here. Write the entire equation in terms of P, not in N, and you will get this conductivity equation for a P type semiconductor. All this summary is been uploaded on my Instagram page. The photos are uploaded on regular basis of all the video topics that I'm teaching on my YouTube channel. The links of my Instagram page is given down in the description box. You can go and check out my Instagram page. My page is Explore Edu to Teach. You will get all the summary videos and the photos on my Instagram page, which can be helpful for you at the time of examination. All the formula sheets, which can be really helpful for numericals, are uploaded on my Instagram page. Please go and check out my Instagram page, and if you like it, do not forget to follow it and share it among your friends as well. So this is what I wanted to teach in this class. The notes of this particular video is uploaded in my description box of this video. You can go and download it from there. If you like this video, do not forget to like, share, subscribe to my YouTube channel and follow me on Instagram as well. The links are given down in the description box. Thank you so much guys. God bless.